Hey Precalculus, these are your 2.4 notes for transformation of functions. For these notes, I would recommend having a couple different colors of pen so that your notes are color-coded. I guess it's not essential, but it'll definitely make it easier to read later when you come back to it. So to start with, transformations are the things that we can do with a graph. It's the ways we can stretch or move or shift or flip different graphs. And so the first thing we're going to start off with is a horizontal shift. Now in this case, my parent function is going to be x squared. So whatever the most basic form of the function is called the parent. Okay. And it gives the graph its overall shape. So we know x squared is a parabola. We know it's U-shaped. So I have the point 0, 0, 1, 1, negative 1, and then over 2 up 1, 2, 3, 4. And we get this nice parabolic curve. Or at least as nice as I can do in permanent marker. Okay. And now if I'm going to transform this horizontally, horizontal shifts happen with the x. So anytime you see a number in the parentheses with your x, or a negative, or anything being multiplied, if it's inside the parentheses, it's going to be with the x, which means it's going to be a horizontal movement. So for instance, I picked up my orange marker, so I'm going to go with the orange graph. This plus 4 is going to shift the graph 4 units. And inside the parentheses, it's always going to do the opposite of what you think it would do. So normally we would think plus 4 would go this direction, would go to the right, but it's actually going to go left. So this guy right here is going to go left 4 units. So that means I'm taking each point on my parabola and going back 4. 1, 2, 3, 4. There's that point. This guy goes 1, 2, 3, 4. This point goes back 1, 2, 3, 4. And this point goes back 1, 2, 3, 4. And we've got one here also. So here's my parabola shifted 4 units to the left. And then for the third graph, here, this minus 2, you would normally think it would go in the negative direction, but inside the parentheses it does the opposite of what you think it's going to do. So it's actually going to go right 2. So I take each one of these points right 2. Let's see, this guy's going to go 1, 2. This guy's going to go 1, 2. And we get our parabola shifted 2 to the right. So horizontal shifts are with the x. The notation for this that you're going to need to know, that you're going to see in the textbook, is they will say something like f of x minus c. And so if you see this just means you're taking your original parent function, and since it's with the x in the parentheses, it's going to be a horizontal shift. Now if c is positive, it goes right. And if c is negative, it goes left. And obviously if c is 0, nothing happens because there isn't a shift. The next ones we need to talk about are vertical shifts. Vertical shifts are with the y. Or usually these are actually easier to see, that they're just not inside the parentheses. So let's get that written down. Okay. So again, I've got the parabola x squared, so I'm going to go ahead and graph it, in blue, trying to stay color-coded. So 0, 0, 1, 1, over 2 up 4, back 2 up 4. And I get my general parabola, trying to sketch that in and make it U-shaped. And now for the first graph, this plus 3, since it's not inside the parentheses, that's how I know it's going to be a vertical shift, up and down. And when you're outside the parentheses, you do what people think you should do. It's kind of like being inside your house and outside of your house. Outside of your house, you act how you're expected to act. And so this plus 3 is really going to go up 3 units. So that means I take each point and I count up 1, 2, 3, 1, 2, 3, 1, 2, 3. And I've got my parabola shifted up 3 units there. And then this minus 4 is going to shift down 4. because it does what I think it would do. Normally I think negatives would go down, so it does. So each point goes down 4 units. Let's see. 1, 2, 3, 4. Well, that doesn't quite look right. Did I graph that correctly? Over 1, up 1, 2, 3, 4, yep. And then I'm going down 4 units. Oh, that's why. My down 4 units only went down 3 units. So let's see, that's down 4. And then 1, 2, 3, 4. Get rid of that guy. What I wouldn't kill for some whiteout right now. And then that looks more parabola shaped. And this guy is 1, 2, 3, 4. There we go, that's better. And I get my U shape. Okay. So, you know, note to self, I might want to work in colored pencil rather than colored ink because you might be able to erase it a little bit easier. Probably don't want to work in Sharpie, but you know, you live and you learn. All right, so we've got horizontal shifts, we've got vertical shifts. The next thing we're going to talk about is reflecting our graphs. So here, the first graph that I have, my parent function is the square root of x. When I take the square root of 0, I get 0. The square root of 1 is 1. The square root of 4 is 2. So here's my parent function. Now notice that this is just the principal square root. It's only the positive square root. There's no plus or minus here because we didn't square root anything. The square root was given to us. If it's there in the beginning of the problem, you don't have to worry about plus or minus. Now for the reflection, since this is with the x inside of the parentheses, that tells me that it's a horizontal movement. And so this is going to be a horizontal reflection, which means these points are going to get reflected over the y-axis. So here's what it looks like if the negative is inside of the square root. Here, the negative is outside the square root, which tells me it's a vertical movement. That means that when I reflect the parent function, it's going to change vertically. So that means this one flips over the x-axis. Here's what the negative square root of x looks like. So with the parentheses, horizontal movement, outside the parentheses, vertical movement. And the parentheses here, I know there aren't any given, but you'd assume that there have to be some underneath that square root because you're square rooting everything underneath. So the parentheses there are implied. All right, for vertical stretching and shrinking, so if it's vertical, it means that it's going to be outside the parentheses. So to begin with, we've got our parent function here, 25 minus x squared. Now, if you're not sure what this looks like, you could always plug it into your graphing calculator, into your y equals, to get the original parent function. From experience, I know this is going to be a top half of a circle of radius 5. So I'm going to go ahead and plot those points. 1, 2, 3, 4, 5. I'm going to get the top half of my circle going on here. Okay. And now, outside the parentheses is a 2. That means I'm going to get twice as tall. Outside the parentheses means vertical, so it's going to be getting taller, and it's going to do what I think it should do because it's outside the parentheses, kind of like if you're outside your house, which means each one of these points is going to get twice as tall. Now, when you say twice as tall, you're talking about the y values. So, for instance, this is negative 5, 0, this is 0, 5, this is 5, 0. Okay. The y values are going to be doubled. So here, when I double 5, it's going to become 10. But when I double 0, it stays 0. 2 times 0 is 0. Same thing here. And so what you're going to get is a vertically stretched circle. It's going to get a lot taller, twice as tall as the original. And there we go. Now, if you wanted to get some more exact points in here, you could definitely pull those out of your XY table. And in fact, that'd usually be a good idea. For the sake of time right now, though, I'm going to skip that. And then here, again, it's outside. The half is outside the parentheses, so it's going to be vertical. It's also going to do what you think it would do, so it means it's going to get half as tall. So instead of being at 5, I'm going to be at 2.5. Although I'm still at 0 here and here because 1/2 of 0 is still 0. Oh, wow, that really started to look like a lemon head, huh? All right. So that's it for vertical stretching and shrinking. Now we've got horizontal stretching and shrinking. These are going to be things inside the parentheses with the x, and they're going to do the opposite of what you would think they would do. So the first graph, our parent function, the one that gives it its shape, is going to be cosine. Now, if you graph this on your calculator, you have to make sure that your mode is in radians to get this curve. And I'm graphing it between -1 and 1 and 0 and 6 pi. So cosine starts at 1, it dips down to -1, and then it dips back up. And then it repeats this pattern over and over again forever. It's just going to keep following this wave pattern. Okay. Cosine of 2x, since it's going to be horizontal, it's in the parentheses, normally I would think 2 would make things get bigger. However, in this case, it's actually going to make it get smaller. And so instead of one cycle of the wave occurring between 0 and 2 pi, now one cycle of the wave is going to happen between 0 and pi. This is called the frequency of the graph, or the frequency of the wave, and the frequency here is doubling. And I'm starting to lose my magic there, so I'm going to go ahead and stop. And then 1/3, you would normally think that 1/3 would make things get smaller, but since it's inside the parentheses, it's doing the opposite, and so it's actually going to get longer by a factor of 3. And so instead of one of my curves happening between 0 and 2 pi, one of my curves is going to happen between 0 and 6 pi. Now, cosine starts high. It reaches its lowest point in the middle, so for us it's going to be 3 pi. And then it's going to come back up to 6 pi. So it's going to dip down nice and smooth, kind of, and then come back up to 6 pi. So that's your horizontal stretching and shrinking. And then the last example here is just looking at a graph and being able to identify how the function's been transformed just by looking at the numbers and not actually having to look at a graph. So here, the first thing we want to identify is the parent function. And on this graph, it's the x's and the exponents without any of the other numbers. So in this case, we have a squared and we have an x. So my parent function is going to be f of x equals x squared. And then after you identify the parent function, you're going to want to follow order of operations when you list out your transformations, or PEMDAS. So in this case, when I'm starting to consider my shifts by order of operations, I'm going to look up here. The first thing I'd have to do is in parentheses. And inside the parentheses, we have a -3. So the first transformation that happens is it goes right 3. I know that because it's with the parentheses, so it's going to do the opposite of what I would think it would do. Normally I'd think -3 would go left, in this case it's going to go right. And since it's with the 3, or with the x inside the parentheses, I know it's going to be horizontal. The next thing that's going to happen after this would be the exponent, but that's actually from the parent function. So this exponent is sort of part of the original function. So then I go to multiplication. Now we're multiplying by a -2. The negative is going to be a flip, and now you have to think, is it going to be a vertical reflection or a horizontal? Since it's outside the parentheses, it's going to be a vertical reflection. And after it gets reflected, you're going to have a vertical stretch. It's going to become twice as tall. It's important that you say vertical stretch here, because sometimes when you look at a vertical stretch, it could look like a horizontal shrink. It looks, sometimes when you stretch things out, they look skinnier. And so make sure that when you're identifying these, that you say it's a vertical stretch, so that I know that you can tell the difference. And then the last thing that happened on this is this 1. I could change this 1. I could scratch it out and say -2 times x plus 3 squared, or x minus 3 squared plus 1. And if you move it to the end, it looks a little bit more, it's easier to identify that this is a vertical shift. So it's gone up 1. And then you can always check your work on your graphing calculator. So I'm expecting this to move to the right 3, be flipped upside down, a little bit taller, and then moved up 1. So in my calculator, if I go in and plug in x squared, and then I plug in 1 minus 2 times x minus 3 squared, and I graph it, The first graph is my parabola. The second graph has been shifted over, it's been shifted up, it's been flipped upside down, and it's certainly a little bit skinnier. Alright guys, that's it for these notes. Make sure that you get them copied down, and then in addition to these notes, you're also going to have practice problems over Thanksgiving break, so make sure that you check the blog for those. Thanks. Good night.